Hello, welcome to The Extraordinaire, where we are committed to the relentless pursuit of excellence. If you love tech, you want to skill up, or you just like learning new things, please subscribe to the channel so you don't miss any of our content. Today, we are going to be looking at errors and exceptions in Python. Until now, error messages haven't been more than mentioned, but if you have tried out the examples, you've probably seen some. There are at least two distinguishable kinds of errors: syntax errors and exceptions. Syntax errors, also known as passing errors, are perhaps the most common kind of complaint you get while still learning Python. For example, let me create a new file here. Example 1.py. While, let's say we write a code, say while true, print hello world. Now my IDE is already warning me about the error here, but let's go ahead and ignore it and run this script and see what we get. I'll cd into the directory and I'll run this script. Python 3 error example 1.py, and we get the error. The parser repeats the offending line and displays little arrows, as we see here. There are some arrows here that are displayed, pointing at the place where the error was detected. Note, this is not always the place that needs to be fixed. In this example, the error is detected at the function print, since a column is missing just before it. The file name, standard in this example, and the line number are printed, so we know where to look in case the input came from a file. So here we have line 1 printed and we have the file name printed here. But in the example that we have here, is showing standard input because it used the interactive terminal. Even if a statement or expression is syntactically correct, it may cause an error when an attempt is made to execute it. Errors detected during execution are called exceptions and are not unconditionally fatal. We'll soon learn how to handle them in Python programs. Most exceptions are not handled by programs, however, and result in error messages. So for example, we want to divide by 10, so we say 10, let's say we want to print 10 times 1 divided by 0. If we run this, we get an error, which is a 0 division by 0, a 0 division error. We also have another example here where we say 4 plus spam times 3. And if we run this, we get a name error. Also, if we try to do string 2 plus 2 and we run it, we get a type error. The last line of the error message indicates what happened. Exceptions come in different types, and the type is printed as part of the message. The types in the example are 0 division error, name error, and type error. The string printed as the exception type is the name of the built-in exception that occurred. This is true for all built-in exceptions, but need not be true for user-defined exceptions, although it is still a useful convention. Standard exception names are built-in identifiers, not reserved keywords. The rest of the line provides detail based on the type of exception and what caused it. The preceding part of the error message shows the context to where the exception occurred in the form of a stack traceback. In general, it contains a stack tracebar listing source lines. However, it will not display lines read from standard inputs. All the built-in exceptions are found in this link here. I'll link this in the description below so you can go through it and figure and learn about all the built-in exceptions that are available in Python. It is possible to write programs that handle selected exceptions. Let's look at an example which asks the user for an input until a valid integer is entered, but allows the user to interrupt the program using Ctrl+C or whatever the operating system supports. Note that a user-generated interruption is signaled by raising the keyboard interrupt exception. So let's create another example here. We'll call this example 2. Example 2.py. And in here, we're going to write this short program that says while true, try x equal to int input, please enter a number. Let's give some space here. Break. Except value error, print oops, that was not a valid number, try again. So let's run this. Example 2, enter a number, let's say potato. Oops, that was not a valid number, try again. If I put in a string, it still says oops, that was not a valid number. Let's try 2 like this. That's not a valid number. But if I enter 3, what do I get? It breaks off because it got what it is looking for. So let me explain what's going on here. First, the try clause, the statements between the try and except keywords, is executed as this section here. If no exception occurs, the except clause is skipped and the execution of the try statement is finished. If an exception occurs during execution of the try clause, the rest of the clause is skipped. Then if the type matches the exception named after the except keyword, the except clause is executed. So what that's saying is that if I imputed, so here we're trying to get an input from the user and we expect this input to be an integer. But if it is not an integer, it throws a value error. When we pass in anything that is not an integer to this function, it throws a value error, which is now caught by this except value error. And so this line of code will now be executed, which prints this oops, that's not a valid number, try again to the screen. If an exception occurs which does not match the exception named in the except clause, it is passed on to the outer try statement. If no handler is found, it is an unhandled exception and execution stops with an error message. So if there is an error that occurs somewhere here and it doesn't match this and there is no other handler to handle the error, the execution of the program stops and there is an error message that's thrown and displayed to the user. A try statement may have more than one except clause to specify handlers for different exceptions. At most, one handler will be executed. Handlers only handle exceptions that occur in the corresponding try clause, not in other handlers of the same try statement. An except clause may name multiple exceptions as a parenthesized tuple. You can list them like this instead of listing them one after the other. and have a snippet of code that runs if any of these exceptions. A class in an except clause matches exceptions which are instances of the class itself or one of its derived classes, but not the other way around. An except clause listing a derived class does not match instances of its base class. For example, let's create a new file here. Example 3.py. So let's say we define 3 classes. We have class B, exception, pass. Okay, then we have another class C, which is derived from B, pass, and then class D, which is derived from C, pass. If we now write a code like this for CLS in B, C, D, try raise CLS. Now here we're going to say except D, print D, and except C, print C, except B, print D. Now if we run this, example 3, we get BCD. For each of the objects in this list, we are raising an error, and that error is being matched to each of these except clauses. So when we match D, we print D. When we match C, we print C. When we match B, we print B. Because D is the lowest derived class, it's going to be printed. Same thing for C. It is lower than B, it's going to be printed. And for B is the base class for all of these other classes. It is printed last. However, if we should change the order of the except clauses here, we would not see different characters like this. Instead, we will just get B for all of them because B matches for all of them. So let's see that example. So I'm going to take B to the top now and have C come next, and then D will be the last. And what we'll have here is BBB all through. When an exception occurs, it may have associated values, also known as the exception arguments. The presence and types of the arguments depend on the exception type. The except clause may specify a variable after the exception name. The variable is bound to the exception instance, which typically has an args attribute that stores the argument. For convenience, built-in exception types define __str__ function to print all the arguments without explicitly accessing args. Let's see an example here. Create a new file. Let's call this example 4. here we're going to say try raise exception spam X. We'll clear this. Close this up. Exception as inst print type of inst print inst dot args print inst, then we say xy is equal to inst dot args print x equal to x and print y equal to y. Let's run this. Python 3 example 4. So what we have here is the first line prints the type of the exception, which we have here as exception. The second line prints the arguments which were passed in, and that is spam and eggs. That's why we get spam and eggs here. The next line prints inst, which uses underscore underscore str function to print the arguments that were passed in. So that gives us the same as the .args attribute. Next, we assign the arguments that were passed into the exception object to variables x and y. Then we print those variables to screen, and so we get x equal to spam and y equal to x. The exceptions str function output is printed as part of the detail of the message for unhandled exceptions. Base exception is the common base class for all exceptions. One of its subclasses, exception, is the base class for all the non-fatal exceptions. Exceptions which are not subclasses of exception are not typically handled because they are used to indicate that the program should terminate. They include system exit, which is raised by 6.exit, and keyboard interrupt, which is raised by when a user wishes to interrupt the program. Exception can be used as a wildcard that catches almost everything. However, it is good practice to be as specific as possible with the types of exceptions we intend to handle, and to allow any unexpected exceptions to propagate on. The most common pattern for handling exception is to print or log the exception and then re-raise it, allowing a caller to handle the exception as well. Let's see how we do that. So we create a new example file here. Example 5, and then we import this. Then we say try f equal open my file.txt, and we say s equal f dot readline, and then I equal int s dot strip, and we say except OS error as print OS error, and we have except value error print would not convert data to an integer, except exception as error, print f of unexpected equal to this type of error, equal to this. So what we are doing here is we are trying to open a file which is going to fail because we are not opening it properly, and we are going to catch that exception. Then we'll try to read a line from the file, then we will try to assign that to a variable as an int, which is also going to create its own exception. And each of these exceptions are going to be handled here. So the OS error will be handled by OS error and it will be printed to the screen, except the value error will be handled by this, and that is where it cannot assign this to an integer. It can't convert the value to an integer, and that would be printed as could not convert data to an integer. And then finally, if there is any error that is not matched in this list, it's going to be handled by this catch all. And here we are formatting the string to display the error and the type of the error. If you've not gone over the video for formatting strings, you'll want to take a look at it. Save. Example 5. So we see we get OS error, which is this one here. It says no such file or directory my.txt. So if we should go in now and create this file, new file, say malfile.txt, we save it, we close it, and then we run this again. We see that we get the next error, which is could not convert data to integer. Okay, that's basically all that we will get at this point. Let me see if I can trigger one error here. Just say raise somewhere here. Just raise exception, and if I do run this, you see unexpected error exception, the type, and then we get the type displayed. The try except statement has an optional else clause, which when present must follow all except clauses. It is useful for code that must be executed if the try clause does not raise an exception. For example, let's create another exception file here. Is example 6.py, and in here we're saying for arg in sys.arg should be 1 this, so we have to import sys. Import sys. Here we say try f equal to open arg for reading and accept OS error, print and not open arg, and then else print arg as len f dot read lines here and say f.close, save that. Now let's run it. So because we are going to be using the arguments from the command terminal, we'll have to pass that in while we are running the script. So we'll say python 3 example 6, and then we'll pass in the name of the file. Let's say hello.txt, and this will tell us that it cannot open hello.txt. Why? Because there is no such file called hello.txt. So let's go now and create a file, say hello.txt, and inside here we're going to say hello, and then we'll say world. Now close this file and we run this command again. We see that it says hello.txt has 2 lines, and that's because after executing the try except statement and not finding any exception, Python goes ahead to execute the else clause, which comes after the except statement. The use of the else clause is better than adding additional code to the try clause because it avoids accidentally catching an exception that wasn't raised by the code being protected by the try except statement. Exception handlers do not handle only exceptions that occur immediately in the try clause, but also those that occur inside functions that are called even indirectly in the try clause. For example, say example 7, let's define a function here. This fails, and say x equal to 1 divided by 0. Then here we try this fails, and we handle that with the 0 division error as error. Then we'll print handling runtime error. Okay, so now if we run this example 7.py, handling runtime error, division by 0, and so we handle an error that was not triggered in the current program but by a function that was called by the current program. The raise statement allows the programmer to force a specific exception to occur. For example, say example 8.py, we can come in here and raise name error, hide. And if we run it, we get the error message here. Raise name error, hide there. The sole argument to raise indicates the exception to be raised. This must be either an exception instance or an exception class, that is, a class that derives from the base exception, such as exception or one of its subclasses. If an exception class is passed, it will be implicitly instantiated by calling its constructor with no argument. So we could do the same thing by saying raise value error without passing arguments, and we essentially get the same thing. Value error was raised. If we need to determine whether an exception was raised but do not intend to handle it, a simpler form of the raise statement allows us to re-raise the exception. We could do something like this. Try raise name error, hide except name error. I will say print an exception flew by raise. Now we can run this again. We get the string an exception flew by printed to the screen, and the error is re-raised. We're going to stop here for errors and exceptions for now, but I'll conclude this in a subsequent episode. If you enjoyed the content, do like, subscribe, and share. and I'll see you in the next one. Bye.